For experiment 2, we are going to do measurements and determination of densities. The objectives for experiment 2 are the following: to become familiar with the metric system of measurement, to become skilled in the measurement of mass, volume, and density, and to be introduced to the use of spreadsheets. So we're going to use Excel in this experiment. In these experiments, you will experience doing measurements. So the measurements that scientists make using different instruments enable them to determine the properties of substance and to deduce other related quantities. Okay, so meter stick is used to measure length, burette, pipette, volumetric plus, and grad cylinder like here, they are used to measure volume. Different types of balances that we have here, they're used to measure mass. Okay, thermometers are used to measure temperatures. Now in this experiment, you're going to what we call use an instrument that's known as a caliper. Okay, so used to measure length, usually the small or shorter length, in this case centimeter level or shorter than that. And we're going to use the system international system of units, which is abbreviated as SI. For the procedure of the experiment, there are 3 parts of the experiment. So for the first part, what you're going to do is you're going to be given 5 ball bearings of various sizes from your instructor, and then you're going to weigh each of these ball bearing, starting with the smallest one on a top loading balance to the nearest 0.01 gram, and then you're going to record the weights or the mass in the report sheet. And then you're going to measure the diameter of each of the ball bearings using the vernier caliper. So there's a video on how to do this. You record your values in the report sheet. And then you're going to have a spreadsheet. You're going to open Excel. You input the data that you obtain. Okay, the diameter and the mass. And then you're going to process it to get the surface area and the volume. Okay, so if you're going to look at it, so surface area is just equals to what? So you have in your Excel, the column there, you have your diameter, and then you will convert it to surface area. Okay, so how are you going to do that? During the surface area, so surface area will be 4 times pi times 1/2 of the diameter squared. Okay, now for the volume, you're going to get it by 4/3 times pi times r squared, or the radius, or 1/2 of the diameter. So once you have this set of data in your Excel, you're going to plot mass versus the diameter, mass versus the surface area, and mass versus the volume. Okay, and from this you should be able to get the density. So you're going to have the y equals to mx plus b, which is really mass equals to density times volume plus b. In the next part of the experiment, you're going to determine the density of an unknown liquid. So you're going to have here a graduated cylinder and dispensing material, okay, to put the amount of liquid into the graduated cylinder. So what you're going to do first, you record the mass of the 10 ml graduated cylinder in your report sheet. And then you're going to add about 1.5 ml of the unknown liquid. And then you're going to weigh the cylinder with the liquid in it. So once you know the mass of the cylinder plus the liquid, you subtract it with the mass of the cylinder, you can get the mass of the liquid. Now you're going to repeat this again 5 times by adding additional 1.5 ml of liquid to the same cylinder. So what does it mean? 1.5 weigh, 1.5 weigh, 1.5 weigh. So there's an increment of 1.5 ml, and then you're going to record the change in terms of the mass after you add 1.5 ml. Now you're going to place the volume in column B and the mass in column A, and then you're going to plot volume versus mass and determine the density of the liquid. Now, the last part of the experiment is just determining the density of solid, and usually this is for irregular solid. So the way that we're going to use this is based on the water displacement method. Okay, so the volume of water that changes after you add an irregular solid, that is equals to the volume of that irregular solid. So what you're going to do, you get a grad cylinder, you fill it up with water, you read the volume before you add any solid to the cylinder. You record the value in your report sheet in terms of the volume, and then you measure the mass of the cylinder and the water and record it. What you're going to do, you're going to put several pieces of the unknown solid in the cylinder. You read the new volume and record it. You weigh the cylinder and the solid, okay, with the water on it, okay, and record the mass. And then you continue going on, add another piece of solid and repeat steps 2 and 3 a total of 4 times, and then you record the cumulative mass and volume. Once you have that, you use Excel and plot the mass versus the volume. Determine the density of the solid. Shown here are the data that you're going to use for the first part of this experiment. So here the mass is given in terms of grams, while here the length of the ball bearing is given in terms of centimeter. So you're going to use this value to plot to enter in Excel, to process to determine surface area and volume. And once you have that, you're going to plot them. Okay, mass versus the diameter, mass versus the surface area, and mass versus the volume. And then from that, you're going to get the density of the ball bearing. So here, you're given the raw data for part 2 of the experiment, wherein you have the mass of empty cylinder, which is just all the same because you just use the same graduated cylinder. And then here, the mass of the cylinder from the added plus the added liquid corresponding to the volume of liquid that was added. Okay, so one is missing here is the mass of which you're going to supply. So I'm going to give you the sample calculation for this part, and in your report I want you to use the other set of data, not the one that I gave to you. So if you're going to look at this, you have what? 91.50, okay, minus 89.60. And if you're going to do the operation, it's around 1.90 grams. So if you're going to put here, you will have it. So you're going to supply the information that you have here, and then you're going to plot this in terms of what? Volume, mass. Okay, so volume is in the x-axis while mass is in the what we call y-axis. Mass. So the last part that we have here is getting the density of an unknown irregular solid. So the way that we're going to do is just multiply the number that we have here with the initial value that you have here. Okay? So for instance, if I want, let's say, this number 110.63 minus 105.60, so I will have what? 5.03. So I get that, subtract it with that. You have to show that in sample calculation. And the corresponding volume would be 21.89 minus 20 is just 1.89. Then what are we going to do here? Okay, we're going to plot this. Again, we have the volume on this side and the mass on this side. Okay, and you're going to calculate for the density. Okay, so what are the stuff that you're going to submit for the lab report for experiment 2? So you have the data, okay, as much as possible no blank data. So if you have blank data there, you have to supply the information on the blank data. Sample calculations, okay, and then we could say the answers to question. And then what else? So in part 1, you have the Excel. You can copy and paste the value that you have there. I'm going to accept that. And then in that you need to do what? 3 graphs. What are these graphs? So mass, okay, diameter, and then mass, surface area, and then mass, volume. And then part 2, you also have mass and volume, and then part 3, mass and volume. Now in all instances, you also need to supply the densities for the 3 samples. So for the first part, for the ball bearing, okay, for the second part, the liquid, and for the third part, for the irregular solid. Okay.